Okay, the next talk is by James Cleverly of Reflex, and it's compellingly titled Truth Machine 2.0.
Excellent, thank you, David. So what's the truth machine? For geoscientists going into a prospect that has been mapped geophysically, the first drill hole you put into that prospect really is the first time you're acquiring a sample and really understanding what the truth of the geology is. So the drilling process itself has always been called the truth machine. It's the first time we get a bit of truth. And what we're talking about here is, what does Truth Machine 2.0 look like? Where is our industry going, and where is the technology going, so that we're starting to look at what the 2.0 version of the drilling system looks like? And what I really want to reflect on in this short talk is where the technology is going, what that means for the business of discovery, and what it means in terms of making near real-time decisions. And so just really to kind of raise some points that we all need to consider as an industry with this technology kind of advancement upon us. What we're really doing with the technology development at the moment is solving a systemic problem that our industry faces. And that is that the process of drilling to acquire a sample is part of a cyclical process. You drill to acquire the sample, you measure something in that sample, you interpret the measurement to make a decision about either targeting or the way you're modeling your ore body or the way you're blasting your bench. And then you re-drill. You move it to a new target or something, you make a decision. And that cycle, regardless of whether you're in greenfields exploration, diamond drilling, or drilling a blast hole, that cycle currently in our industry really takes too long to move around. To wait 4 months to make a decision on some data in a greenfields diamond drilling program is too long when you're only drilling for 3 months of the year or something. Getting data back on blast holes, 72 hours is probably 48 hours too long. So the technology development is really about bringing everything together to improve the speed at which we move around that cycle and deliver the information to the geoscientists to allow them to make decisions a lot quicker. And another buzz phrase we'll hear a fair bit is Industry 4.0. This is the kind of the evolution of our manufacturing industries. And the reality is that the kind of technologies that we're dealing with in Industry 4.0, which is robotics and automation, it's about convergence between IT and OT, it's about the connectivity of technology. Those technologies are with us right now in our industry. And there's a couple of examples just up there. There on the left-hand side is some real-time geochemical data delivered from a diamond drill rig. That's actually using the lab at rig system there. So that geochemical plot there, I've run a wavelet tessellation on some of the data there, so you can see critical lithological boundaries. That data is sat there for the geologist the first time they look at the diamond drill core. They've immediately got that data to support their process of geological logging. On the right-hand side there, you can see some natural gamma traces. And so that's a tool that we've got, which is a driller deployable natural gamma tool. And in that instance there, it's being deployed on an air core rig, so that the geologist following the air core rig immediately has a profile trace that allows him to not only map the regolith, it can assign his chips to the different regolith units, and also immediately understand which of those piles of chips are the best chance of getting lag samples from in that instance. And so already the technology we have is allowing us to start to make these real-time decisions. So the Industry 4.0 technology and infrastructure is really upon us. And as an industry, we need to recognize that it's not something that's going to be happening in 5 years' time, it's happening right now. And I guess one of the other really critical things we're seeing happening around this infrastructure is that we're moving ourselves away from just delivering data. And it's great to deliver data, but we need to be delivering information. To make a decision, you need to turn the data into information. And so there's just another couple of examples of using some analytics in Iogas there to turn lab at rig data into information to support the decision making of the drilling process. So there's 4 drill holes. Those coloured bars there are a SOM classification of the lithogeochemical elements. So you can immediately have a cross correlation between those drill holes to understand which geological units are which without having to wait several months for that data to come back. So you can start to make decisions as we're drilling, start to classify. So that information is required to support the decision-making process, and more, the process of doing the analytics will need to be moved into the cloud environment. Well, edge computing is probably actually where it's going to end up, to allow us to run quite detailed analytics on our data and provide information in real time. So what does this all mean then for the process of real-time decisions? So in an exploration project where you're drilling 4 holes, to have that real-time information allows me now to make a decision about either where I'm going to drill hole number 2 and 3, i.e. change my program, change where I'm targeting, or probably more importantly actually not drilling drill hole number 4, and the savings of not having to drill that 4th drill hole. And to support that real-time decision workflow, there's actually a lot of aspects to the business that we need to deal with. There are regulatory processes that will need to change across the globe. We have to be in a situation where we can make more dynamic decisions, we're not fixed into programs, and the kind of technology we're developing will mean that actually we've got lower footprint drilling, we've got better environmental controls, so there has to be a trade-off, and I think we'll see that, but the regulatory bodies need to respond to that. Internal business processes in our companies will also need to change. The reality is that if we deliver real-time information very quickly to allow a decision-making process, you don't want that decision to be held up because someone hasn't approved a workflow in SAP. So our internal business processes will also need to adapt to this new way of working. Shareholder value is a really interesting one. As a shareholder in a company, I would much rather have my dollars spent testing 4 targets than completely spent on testing 1 target that we know is a dead target right up front. You're going to improve discovery rates by spreading that cost. So there will be an impact on shareholder value, and there'll be an impact back into how we report through to our stock exchanges as well. And I think, Steve, you talked about this, the people and the skills. The people, there will be a change management process that has to happen as we move ourselves through this changing process. Our people will change their workflows, they will have to change how they manage data, they're going to be getting information quickly, there's a change management piece in this jigsaw puzzle, and probably the skill sets of our people. Our geoscientists now will need to be a little bit more numeric, and they will need to think a little bit more about what they're doing. Hopefully the technology will actually allow our geoscientists to behave more like geoscientists and less like database admin people or QA, QC people. So what does Exploration 4.0 look like? So we talked about Industry 4.0. What does Exploration 4.0 look like? Well, I think we can learn a lot from the way that the startup community is behaving at the moment in using lean and agile approaches to starting up technology companies. I think Exploration 4.0 is actually about our ability to rapidly test, to rapidly iterate, to fail fast and embrace failure. We should be embracing failure. But that allows us to test more targets, and that will improve discoveries. So that sort of lean, agile approach that we're seeing in technology startups is something I think that we can bring into the way that we run exploration projects with this kind of technology to support us. One question I've raised a few times is in technology startup companies, there is a role in those companies of a product manager. Product manager is the person that runs around making the right technology, making sure it's commercially viable, making sure that everything works correctly. Who are the product managers in our minerals business? At the end of the day, we're just a manufacturing business, the product being our commodity element. So it's a really good question for us about how we tie all of this together and who our product managers are. And I think that's probably the exploration managers of the future, behave more like product managers. Quality product is actually what we're trying to produce here. All good. Last slide, Richard. So we're faced with a road ahead of us. We're on the road. The technology is here. The infrastructure is here. We do need to embrace it. It is going to be the change that our industry needs, actually, to survive. And the road is lit ahead. But there are a lot of ancillary aspects to our business that we need to address, I think, as a community to understand how we can successfully embrace the technology that already exists. So I'll leave it there for you to reflect on those points. Thank you.
Any questions for James?
So I think one of the things that we can do as a community is that and I did mention it a bit, the technology. So imagine a low footprint coil tube drilling system running out there. We're not digging the big pads, we're not digging the sumps because we're using SIUs. Our environmental impact is a lot less. And I think as an industry, we need to go back to the regulatory bodies and say, actually, this technology is allowing us to do things quickly and fast, but also with less environmental impact. And there's benefits back to you guys, and we might not drill as many holes, actually. There's benefits back to the states and the territories. Can we now work with you on that regulatory change to take that into account? So if you mandate the use of an SIU, that would be a terrible thing for AMC, of course, but if you mandate the use of an SIU to be able to get a regulatory change in the way that your permitting is done, and those are the kind of things that would have to happen. And there are places where that happens. In Nevada, for instance, they do require the use of a centrifuge. So I think that's the way we do it, but we have to do it as a joint community between the Mets and the industry, going back to the government.
Which one worries you the most?
I think in the shortest term, it is the change management of people. That's the bit. We don't like to change. And the change is happening very quickly, and these new workflows are being put on us very quickly, and people are really grappling with how to do that. And you can't just go and deliver the technology and expect someone to get on with it. There's a change management piece there that is required from all of us to help that happen.
Any other questions? Thanks, James.
Okay.